Hello and welcome to another video regarding operational amplifier. Today we're talking about non-inverting operational amplifier. So when it comes to non-inverting operational amplifier, it is mainly used to amplify a signal, as you are going to see here. Because you can see that this time when it comes to the two terminal inputs that we have, which is inverting input and non-inverting, that means since we are designing a non-inverting operational amplifier, we supply voltage source to the non-inverting terminal. Then we come to the inverting terminal, we connect it to a resistor, we refer this as R1, and then we have also a feedback resistor as well, which is RF. And looking at this circuit diagram, what you can observe is that here you can see that since the input voltage is being connected to the non-inverting input, what that means is that you have an output voltage, which is what? VO, and that output voltage is now feeding RF and then R1 with voltage supplied. That is how the non-inverting operational amplifier works. So in order for us to get a relationship between the output voltage and the input voltage here, so what we do is that we go back to the very definition of open loop voltage gain, which is going to be equals to output voltage over differential voltage. So we have VA being equals to what? V1. And when it comes to this V1, you can see V1 is a voltage input to the NAT and to the inverting input terminal that we have. And this time it's not going to be zero because you can see V in the mean there. Non-inverting input terminal is no longer grounded. We have a voltage supply, which is V in. So we come here, output voltage over this. Then we can write the differential inputs, which is going to be V2 minus V1. And now it's going to equal, we can see V2 here, which is the voltage that is being connected to the non-inverting, and that very voltage also V in. So V in is actually equals what? V2. And here to when you come to V1, that is just going to equals what? VA as well. And we can now try and get the voltage at node A. The voltage at node A here, since the output voltage is supplying voltage to RF and R1, and with I being equals to 0, then we know that IF will equals what? R1 in that case. So I can put here I1 and I'm add here to what? IF. So with this situation, you can get the output, you can get VA, which is going to be equals to, the VA is going to be the voltage across R1, right? And R1 will be equals to what? We use our understanding of applied electricity. That means you can see that RF and I1 are in series because they have the same current passing through them. In that case, if I want to find the voltage across R1, that is going to equals what? Its resistance, which is R1, over the sum of the resistances which are connected in series, and now going to what? R1 plus R. Then times the voltage supply to those series connected resistors, and that will what? The output voltage. So we get VA to be equal to this, and we can write this. We can replace beta to be equals what? R1 over R1 plus RF. So that we just have beta times the output voltage. So we come here and then expand on the open loop voltage gain, which is going to equals output. That is open loop voltage gain times differential voltage. And we do replacement, and we realize the output voltage will be equals to open loop voltage gain times V in over 1 plus beta, right, output voltage, right, times the open loop voltage that we have here. And as a result of this, then again, here using our notion, our understanding of mathematics, we can see here if the open loop voltage gain is an infinite value, that means 1 plus an infinite is become insignificant. So we just have beta times what? open loop voltage gain. That will cancel this. So we just have V in over 1 over beta. And we can replace by beta. Beta is 1 R over R1 plus RF. And that will give us this. So we end up getting the output voltage be equals to 1 plus RF over R1 times 1, the input voltage source, which we have here. And this is going to give us the output voltage. We can equally get here closed loop, right? Closed loop voltage gain, which is this L, that will be equals to open, and that is going to be equals to output voltage over input voltage. And if we make that relation here, the sum gets, so you get open output voltage over input voltage source, I will going to be equals to 1 plus RF over R1. And that is going to be the same as closed loop. And this is how we are able to come out with a formula for a non-inverting operational amplifier. See you in the next video. Bye-bye.